Okay, so
I got A right.
that's everything I got so far. Thank you for this. How was this project? How was dimensional analysis? That good? That good? That was good. Is okay. Anybody that hasn't reached their billionth second yet, I highly recommend a very special party for it. Call your parents. Find out what time you were born. Do plus or minus 60 seconds around that, and just party for that full 2 minutes. That's okay. It's fun because I celebrated. No, I missed Max's 1,000th second because that's about 3 minutes or something after he was born. I was totally passed out because as soon as he was born, he passed out. I caught his millionth second, which was something like, I want to say it was like 21 days or a month and a half in. A million seconds is not that long. And isn't it amazing that 1,000 seconds is, a couple minutes. A million seconds is a few days, maybe a month and a half. I forget exactly what it is. But a billion seconds is almost 32 years. Isn't it crazy? It's crazy to think about, but that's what you have to think about when you watch the news and they talk about dollar amounts they're spending. Oh, we've spent so much. We spent 1.2 million. You haven't spent squat. In the time it took you to say that sentence, you've overspent 3 times that much. So a million versus a billion, and now, good Lord, versus a trillion. None of us will live to 1 trillion seconds, unless we're Yoda. But that's the only way we're going to live to. A trillion is 1,000 billion, right? Every illion is 1,000 times the illion before. And I think that's part of the problem is we've created, and this is the problem with language. I honestly think the word should take proportionally longer to say if it's bigger. Like the word quadrillion, which we're not that far from, I'm sure, as far as deficit spending goes. I'd say within our lifetime, unfortunately. But the word quadrillion, I mean, it's scary. It's 1,000 trillion. A trillion is 1,000 billion, so a quadrillion is a billion billion. Or excuse me, it's a million billion. And that sounds like Dr. Seuss talking, million, billion, billion. It sounds like me and my son. Dad, I want you to do 1,110 push-ups. I'm like, okay. I need like a week and a half. But that's what it becomes. It becomes a little ridiculous. If you see it written out like I made you guys do, that's the way you really, truly appreciate how big or how small those numbers are. Yeah. And I like some of these examples. Some of them remain constant. I love the billion seconds. That's like one of my favorites. But the one about the oil slick, that's a relatively new one. That's a relatively new one, and it just goes to show you that does represent an idealized situation of dropping a barrel of oil into a perfectly still, infinitely large puddle of water. Now, the ocean is not like that. It has waves, so it wouldn't actually have the chance to get perfectly. How big was that circle? 28 miles. 28 miles. That's 1 barrel of oil, 55 gallons, right? 55, I think. 55 gallons of oil spreads out through 28 miles. I mean, that's insane. And then now you got to realize that we don't spill 1 barrel at a time. We spill lots of them when we spill them.
I thought you said 40. I thought it was 42 gallons.
Maybe I'm going by memory, so
okay.
always suspect that. 42 gallons. That's even worse.
Yeah.
That was in the problem. Good. That's even worse. It's all good. You do it. Whatever. The fact of the matter is, 42 gallons is not that much, and 28 miles is a hell of a lot. Please, Amber.
The crazy part was like how thin it was. And how, I mean,
that's what it tries to do.
Under at all.
That's what it tries to do. Well, its density is less than that of water. That's the point. That's why it separates. I mean, it's like Italian dressing at that point,
yeah.
Right? It's the same idea. It's just that Italian dressing you shake, and the ocean gets shooken as well. Shaken. Gets shaken. That's what gets shooken. Talking to my 6-year-old too much. It gets shaken as well, but it tries to do that, and that's hence why oil slicks are so freaking terrible. That combined with the fact that it's a highly viscous liquid that sticks to everything, and it's hard to clean up. There's all kinds of reasons why they're bad. Now, I've had it argued that, the Earth hemorrhages oil naturally every year, and it does. When the BP oil spill happened back in 2010, the BP rig at Deepwater Horizon exploded, and for 86 straight days pumped oil into the Gulf of Mexico. I've been told by a number of people that the Earth dumps that much oil out. If you look at all the leakages of all the oil leakages all over the globe at deep depths, it hemorrhages at least that much oil every year. I'm like, yeah, but not in one place. It doesn't all happen in one tiny, relatively contained area that then washes up on shore and kills wildlife. I mean, don't try to make it sound better than it is. It's pretty freaking bad. So the idea of this project is to give you an idea of how to experience your world. Now, not everything was supposed to be depressing, obviously, like the oil spill. The one with Max and the algae. That's one of my favorite uses of, that was on there, right? How big a pump do we have to get for our pond? I mean, he thought it was magic, which is adorable. And at 6, he doesn't realize the difference between math and magic anyway. It's all just like wonderment for him. But just the fact that you can do that kind of a thing. You can do that. You can time filling a bottle and then extrapolate out from that to get numbers. I mean, it's just the kind of stuff that you don't think about all the time, but you totally can. And sometimes it's silly, like, you know, how much does the, what was the opening question? How much does the block weigh or how big is the block in the pyramid? You know, I mean, I've never been there, so it's all wonderment at that point. But a lot of times it raises questions. Limestone, which is what those blocks are highly variable in their consistency. I mean, limestone can be extraordinarily compact and dense. It can be pretty friable. The acid rain changes the density a lot of times. Egypt just got its first snowfall in like 100 years. Did you guys see the pictures? It was I think it was in December of last year. Egypt got its first snowfall. The pyramids covered in snow. Google it. It's freaking beautiful. It's really, really cool. But all those things vary. I mean, they over time, variability can change. So you have to make adjustments when you're doing that. Putting a hose in an Algene bottle is different than watching the effect of limestone. I remember climbing in American Fork, Utah, on this rock climbing route, and I was 30 feet up, holding onto, I call it a luggage handle. It's this great hole that's shaped like a luggage handle. You don't see them at Smith Rock. There's Smith Rock's tiny. Maybe rock climbers in here, a couple rock climbers, couple. I hang on this luggage handle, and I was climbing next to a guide from American Fork, Utah, and so I was 30 feet up. My last clip was at 20, and I had rope in my mouth, and I was reaching down, and I went to clip, and this luggage handle broke, just sheared off my hand, and I just went, and I think my wife back there saw it happen and ran away from the cliff with the rope. I ended up at the ground, not on the ground, but at the ground. So I had fallen 30 feet, landed right at the belay. My son was still sleeping behind us. First thing I thought was that thing hit him when it came off. And the guide was like, I've been climbing that route for 30 years, and I've pulled on that hold. Limestone, pure limestone. And that's the problem. Acid rain changes the density of these things. I mean, it just eroded it away, and I happen to be the 175 pounds yarding on that hold. It's amazing. You have to kind of, 175 pounds yard on the luggage handle. But that's the kind of stuff that you have to take into account when you're doing things. Things like water and an algae, there's something to take account for. Water has a density. I mean, but limestone, you have to kind of make the adjustments for. But once you've made the adjustments, you can make interesting conclusions from that, and you can actually talk intelligently about it. That's how I knew when BP got on the news back in 2010. They said, we're leaking about 1,000 barrels a day. I was like, I call BS on that. I've seen the YouTube video that you guys posted, and I know it's at least 10 times more than that. And then I had my 240, I came into class one day, I was all depressed. I had the 244 kids run some math, just crap. And I was pissed because I knew that they were lying with 1,000 barrels a day, and my kids figured it out. And we submitted our results to BP, and BP kept putting on their websites little updates. And finally, by the end of that 86 days, they finally admitted to what actually was coming out of the well. And we were really, really close to it with our estimates. So I guess it's a two-edged sword I'm giving you. I'm giving you these wonderful tools to understand your world, and at the same time giving you agita, potentially. Because once you understand the world, you realize how many decisions are made poorly in lieu of mathematics. So I apologize in advance. Anybody that watches the news is frustrated now.
I don't want to say that oil spills are bad or nothing.
Well, they are. They can be.
Because they are.
Yeah.
But one of the interesting things that always seems to happen after an oil spill, like 4 years afterward, the fishing industry will have that area up their best
Really?
year ever. So Alaska, that happened. They had one of their best
The
years
Valdez.
4 years later because of the micromolecules that actually eat oil, and then algae feed.
Interesting.
And the fish and wildlife feed on those, and so it ends up balancing out eventually. But it's still, I mean, the amount of birds that it kills and those type of deals, but it will end up fixing itself.
You said something interesting, Tony, when you said 4 years later, they'll have the best fishing ever. I forget exactly. The first thing I thought of was, I think I told you guys the Sports Illustrated paradox, right? As soon as an athlete's on the cover of Sports Illustrated, almost inevitably they have the worst week of their life the next week. And the reason, that's the first thing I thought of when you said that, because they regress to their normal. So they're on the cover of Sports Illustrated when they're at their peak. They can't sustain that peak, because they're at the peak. By definition, a peak is something you aspire to and then you can't hold on to, usually. You might be very, very good at your sport, but you're going to have those fantastic performances that get you on the cover, and then you revert back down to your normal kind of fluctuation. The first thing I thought of was, after an oil spill, that the industry gets hammered, and the fishing gets terrible.
It does.
So that way, 4 years later, when it begins to revert back up, maybe it just is comparatively impressive. I don't know. I'm
Yeah.
throwing that out there. I don't have the numbers, so I don't know.
It'd be interesting to look at the numbers.
That's what I like to hear, right there. It would be interesting to look at the numbers and how they're being measured. I would love that. That's the best thing you can do. Whenever somebody supplies you with a Facebook graphic or anything like that, always go try to find the data that it comes from, right? That's the only way you can be sure that a claim has any merit versus no merit at all. It's the only way you could possibly do it. So thank you for that. I appreciate that, brother.
And always look at the axes.
Oh God, yeah. Oh, for
Really
sure.
started at 300.
For sure. And look at the sampling methodology. Look at everything. Look at everything. And take 243 and 244 because it really teaches you how to do all those things. All right. Now, I want to wrap up modeling today. That's my goal today, is to get through the rest of modeling so we can get into probability and statistics. I mean, we've been hinting at it ever since the first couple days. But I've been focusing so much on modeling. But I think with good cause. I mean, I think we've got some more little exercises and points of modeling. I want to make sure that we bring it full circle today, so that starting next week we get the probabilities and likelihoods. Your next project is tied to that too.